Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and if you've been following the channel recently, you know I've been working on a project in an attempt to CNC the X-axis on my surface grinder. Now I'm standing here at the mill now, but we'll get over to the surface grinder in a minute. The process of setting up the CNC on that X-axis is being done with a NEMA stepper motor, NEMA 23, and a Raspberry Pi, and a Python program that I'm writing. All that seems to be working fine. The problem I'm running into, and it's a major problem, is simply getting material, the little pulleys and the belts that I need for this operation that would go. Let me grab one right quick. Little pulley similar to this. This one is like a 2.06 pitch, and I need a 3 pitch, and I need a belt. I'm trying to go a 3 to 1 process, 3 to 1 reduction between the stepper motor and the surface grinder. But all that's going to come about in some future videos. As I say, I'm having issues right now getting the stuff at ordering it on eBay or Facebook, and it seems to get halfway here from China to some import station in California and then never hear from it again, or custom station in California. So hopefully I'm down to one piece that I need now, and hopefully that'll be in within the next week or two. But in today's video, I want to do a little prep on the surface grinder itself. And what we're going to be doing is mounting some limit switches. The way this program is going to work, I had originally planned for the stepper motor to step so many steps in one direction, change direction, and go exact number of steps in the other direction. Now when I get the right pulleys and belts, that might work. But what's happening now, I'm getting some slippage in that finer tooth belt, and so it goes the number of steps it's supposed to over here, but when it tries to stop that 60-75 pound table, there's a little bit of slippage in there. So when it comes back, it don't come back quite to where it started, and it gradually loses down to I'm over here instead of being over here. So I've changed up. If you saw last week's video or my previous video, you know I said I had to drop back 10 and punt. And so what I'm doing now is not necessarily counting the steps back and forth like this. I'm just setting some bumpers up, or I plan to set some bumpers up, and let the table move until it hits a limit switch. When it hits that limit switch, the software, the program that I'm writing, will detect that and move it back in the other direction. Now here's a short little video, very short, is again part of what I posted last week, but it just shows the concept of the stepper motor stepping over it, bumping a limit switch, and changing directions and going the other way. Watch this right quick, and I think you'll understand the rest of today's video a little better. Now the little switches that I'm using in that little demonstration program are normally open. Now what that means is, in its resting state as it is right here, there's no continuity between these two terminals. But when the button is pressed, as what happens with that arm in that demo you just saw, the switch is closed inside and continuity happens between these two terminals. What I need, and that's what I need on the surface grinder, I need the switch to be normally open so there's no power flowing through the switch. But when the switch is bumped, it will make continuity, and my program will detect that, stop the action, back off just a little bit, and then repeat its back and forth. The switch that I'll be using on the surface grinder is just like the switch that I installed on the mill when I put the X-axis power feed on here. This is just simply a dust cover. I'll set it out of the way for now. But watch what happens. This switch is in the normally closed position. Internal switches, like inside this, will normally have 3 contacts. They'll have a common. Then they'll have one pin that's normally closed, meaning power can go through this pin, through the normally closed pin. When the switch is activated, it no longer goes through the normally closed pin and goes through the normally open. The normally open now becomes closed when that pushes down. The switch that I'll be using, like I say, is just like this one that's on the mill, and it is normally closed, meaning electricity current is allowed to flow through that switch from the switch that's over here on the table control to the motor inside. But when the mill gets to a certain point, notice what happens. It pushes that switch, and the spring action that's on here allows it to do it a whole lot more gentle than in that little video you just saw. So what we want to do today, or let me show you when I back this off. Now it would continue that way until the bumper on this side hit that switch. So what we're going to do today is look at how I'm mounting this. I actually went inside the switch that's going on the surface grinder, and as I say, normally limit switches like this have 3 terminals: the common terminal, a normally closed, and a normally open. I switched, actually they weren't plug in, they were soldered on, but I switched from the normally closed position to the normally open. That's 2 different switches in here, one stacked on top of the other. I'll try to insert a quick little before and after picture here, or a before picture. It's hard to see, but basically in that top switch, what I did was move the blue wire from one position to the other, and then the bottom switch that was under there, I believe was a green wire, moved it from one position to the other. So let's look over at the surface grinder now. All right, over here at the surface grinder now, and as you can see, the surface grinder has a track in here built into it, just like the mill does. But instead of limit switches, what this is being used for is simple hard stops. It's got a solid post in the middle and solid stops. And of course, these stops can be adjusted for longer strokes. Now, what I want to be able to do is have limit switches instead of these hard stops. So this little post comes out, and what we'll do is mount the equivalent of what was on the mill over there, what we saw on the mill. This has a dust cover available for it as well. And this is the limit switch. But what I want to do, instead of these hard bumpers right here, is take something like this. This is a piece of angle iron right here that I simply cut the size. Just a 90 degree is all it is. Put a mounting hole in it for, use that screw out of here to mount in here. And what we want to do in this video is make this pin that'll go in each one of those with the spring and the E-clip on the back side. So we're going to go over to the lathe now and turn a piece of material to make this spring-loaded plunger that will come in contact with the limit switch. Okay, I've got a piece of round stock loaded in the lathe now, and I've taken a few measurements which will be just a little bit different than this piece. My measurements will be based on the springs that I had and also the thickness of the bracket we'll be using. What I've determined is that the smaller portion of this will need to be 2 inches long. The outside diameter here, or the wide diameter, we'll go with the same thing, which is 640 thousandths. So I'm going to turn the whole piece down 640 thousandths for about 2.5 inches. All right, we need about 47 more thousandths off of that. All right, I knew something wasn't going right there. Evidently, I didn't have the chuck tight. These are the kind of things that happen when you got the camera going. I've got a witness mark now, or I've got a stop here so I can move this carriage stop out of the way. Alright, now let's set our carriage stop up on the 2 inches that we need for the small portion. Okay, it does appear our workpiece had slipped on that first operation, so I need to get that out just a little more. Obviously this is not rehearsed, so you're seeing it as it happens, mistakes and all. Okay, now let's set up our carriage stop at the 2 inches. We'll zero out the DRO right there. Come in to 2 inches. Make one more cut and then we'll take a measurement and set our DRO. The diameter of the pin that we need to fit the springs that I have is about 306 thousandths. That's 554. We've got about 188 thousandths to go. So we'll start with 60. Like we still got about 15 thousandths to go. I'm wanting that to fit in this 5/16 hole that we've drilled here. So it's need to take just a little bit more. Yeah, I misread that a while ago. I need to get down to about 310 thousandths. I got another 50 thousandths to go. I misread that a while ago. You may see the workpiece deflect a little bit. I got a lot sticking out there. I'll make a couple passes if it does look like it's deflecting any. Alright, that's going, but the spring isn't quite going yet. And of course the spring has got to go over it. Let's take about another 10 thousandths. Alright, shoulder should be cleaned up now. Oh yeah, we're going over it now. Alright, according to my measurements, I don't want to put but just a minimal amount of preload on this spring. That's kind of warm right now. Plus, I think I'm going to take just a couple more thousandths off of this. That's 3 thousandths right there. Alright, with that bottomed out right there, to get about a 1/4 inch of preload on the spring, plus the thickness, excuse me, the thickness of the bracket and the washer, I need to come out to 1.785. I'll need to change tools before I take that measurement. Alright, put my tiny little parting tool in here. And zero that out. Now let's come to 1.785. Should be right there. And what we want to do, I'm going to be using a 1/4 inch E-clip on this. Now I'm going to zero that out right there. And the difference between the 1/4 inch clip and this piece is about 55. I'm going to take my little triangle file and just ease that groove just a little bit there. So what we have now is our spring should go on. Our bracket should go on. Then we'll put a washer on and the E-clip. Alright, I'm going to part this off now. Okay, I extended the workpiece out just a little bit on the lathe chuck. Got the parting tool right with the edge. And I'll come over 125 thousandths. Make this piece about 1/8 inch thick. And we'll gently part it off. Alright, we'll turn our workpiece around in the chuck, clean that little tit off the end, and give it a little dress up. Alright, I'm going to cool that piece off just a little bit, let it cool off, then we'll take a look at it. Looks like it's going to work out good. Slid our spring over our bumper. Slid it through the bracket, put a washer on, and then the E-clip. So now it's held in place, got just a little bit of preload on it. I'm going to take this workpiece, the rest of this workpiece, make another one of these just like that one, and then we'll meet over at the surface grinder and get them installed. Alright, I've got both of our bumper pins made. So let's start by removing this post. It normally has a nut on the bottom of it, but I've already taken that off. Then we'll remove these hard bumpers. And of course again, these were simply made out of a piece of angle iron. It's 1/4 inch thick. Alright, we'll take one of the bumpers that we made. Again, this is what we machined on the mill or on the lathe. Slide our spring over it. Put a washer. And then the E-clip. Do the same thing to the other side. All right. See, I think I need to spread these out just a little more. I think I'll be able to, or I'm not sure if I'll be able to run the cable through this hole or not. If not, I may put one right over here. It's about 1/2 inch thick metal, cast iron. But for now, we're just going to set this up here. I've already drilled and tapped a couple of holes in here. And I'll put the dust cover on after I finish doing all the wiring and get everything set ready to go. Of course, we all know there's plenty of dust on the surface grinder. So there we have our bumpers installed, and again what happens is as this is working back and forth, when it comes to this direction, when it hits this limit switch and closes the contacts in there, the program will detect it, it'll stop its action, it'll stop monitoring the switches and back off just a little bit, just enough to get off that switch, change directions, come back until it hits that switch again. If I don't give it that opportunity to back off, that switch will be on, or if I continuously monitor these switches, then it'll see, okay, the switch is pushed, change directions. Before it can get off of it, it'll see the switch is pushed, change directions again, and it'll just sit there bumping. What this will do, again, it'll come in, makes contact, everything stops in the program. It sends a new command to the direction pin to change the directions, and without monitoring the switches, it backs off enough to get off the switch. Then it continues its loop around until it hits this switch over here. And again, I'm counting on this spring action that's in here now to give a little coast down. Again, this table is probably 60, 70, maybe even 80 pounds with a mag chuck on it. It might even be 100 pounds. but give it a moment to coast down and push the spring if necessary. This handle, of course, will come off. There'll be a mount right here for the stepper motor to mount on, a pulley on the stepper motor, and a larger pulley here. That's what I'm still waiting on. Hope you've enjoyed this little segment on a little bit of machining in this week's video. I'm going to continue the wiring and writing the program, and hopefully be back as soon as I can get the rest of these materials in. Take care, and I'll see you on the next video.